So people have heard of Electron? Okay, no, that's awesome. I don't know. This is very far away. I come from the Melbourne of America, Portland, Oregon. I don't even need to do this slide now, which is great because my talk is too long. So I have talked about Electron in many ways before. Like I had to talk about it internally at GitHub to be like, this should be a team. We should work on this. And I've talked about, what it is, why it matters that it does what it does, and then there's talking about designing with Electron, which is a whole thing on its own, and then developing on Electron. And a lot of this has been geared towards speaking to people coming from Node development backgrounds and people coming from front-end web development backgrounds, and so that's sort of the space I'm into, and so I know how to talk to them, and I would talk in that way. And I hadn't thought for a while about people who aren't coming from Node, people who aren't coming from web backgrounds. And so a few months ago, there were some other GitHubbers that were starting to work on Electron, and I'd done all this, Electron is the best, you should do Electron, it's so fun, it's so easy, you should do it. And they were running into problems, and I was like, whoa, how is that possible? What? And then I was like, have you built web pages before? And they were like, no. And have you worked with Node before? No, definitely not. And I was like, oh, I don't think there's anything out there for you. And that felt crappy. And I felt like everybody deserves documentation. And so that spurred me on sort of a personal challenge to do this site, which is Essential Electron, which was a challenge, or I made the challenge for myself to try and distill Electron into the fewest amount of words as possible, and then especially the fewest uses of jargon. And if there were words I couldn't avoid using, like JavaScript, I wanted to define those things in simple terms and provide links to learn more about that. So I just wanted to say, maybe this is something that we should think about for other kinds of projects. It really was a good personal challenge to force myself to step out of my bubble and the things that I assume that people know, because these other people at GitHub, they were also engineers, they just hadn't come from a web and Node background. And so everyone in this room has a different background and different experiences too. So if this talk is total crap to you, you might want to go to Essential Electron, and I hope that it can be helpful. But all right, so this talk, it's not about designing Electron, and it's not necessarily about 1, 2, 3, get your Electron app started. It's more about how Electron electrons, because the more I've been involved with Electron, the more I've gotten excited about learning how actually Electron makes the development experience it does possible, because developing with Electron can be fun, and it can be easy, and there's all this stuff under the hood that's enabling that. And so that's what this talk is about. But first, we can start at the beginning. Electron is an open source framework for building desktop apps with web technology. And when I say desktop apps, I mean applications that work on Mac, Windows, and Linux, and also ARM. And with web technology, I'm talking about HTML, CSS, and JavaScript. And you might already be, well, we already know everyone. Lots of people know about Electron, so that's great. You are probably using Electron apps. Maybe you're using Atom, which is the text editor from GitHub, the very first thing built on Electron. And Slack is on Electron. The Brave browser, Visual Studio Code from Microsoft is another text editor. WordPress, WhatsApp, there's a ton of cool stuff happening on Electron. And then there are over 220 apps listed on the website right now, from small startups to individual developers. Some of the projects mentioned in Emil's talk earlier have Electron apps also. So typically, native apps, like if you think about your mail app or your calendar app that came with your computer when you got it, were written in the native languages for that operating system. And if you were a project or a company and you wanted to build a desktop app, and you wanted it to work on multiple operating systems, that means building those teams that use those languages. A lot of times it means separate code base. And a lot of times it means maybe you actually just don't ship to all those platforms. But over the last few years, the browser has gotten really awesome, and JavaScript and the web languages are really ubiquitous in many ways. And so people have started trying to combine parts of browsers to enable building desktop apps. And so Chromium Embedded Framework is one here, up there. And they've all done this in kind of different ways. And then there's Node.js is another. There are a few more, but this is the group of technologies that Electron belongs in, technologies that are using all or parts of web browsers to let you build desktop apps with web languages. For Electron, Electron started because it was built for Atom, GitHub's text editor. And the Atom team, way back when, had tried a bunch of the existing things, but none of them were really as fast as they needed or had Node integrated in the way that they needed. And so GitHub contracted Cheng Zhao, who's amazing. He was actually working on Node.js at the time, and GitHub contracted and then later hired him, and he built out Electron for Atom. And it really was, for a long time, just a dependency of Atom. And when Atom became open sourced in 2014, everything got open source with it, so that included Electron. But it was called Atom Shell at the time, and it just kind of was hidden there in the org on GitHub, and it had no website, no one was talking about it. But slowly, people were starting to figure out that actually it was a really powerful tool. And it was really Microsoft building Visual Studio Code, and they were going to launch it. That made us realize, like, those of us on the Atom team, that we needed it to have a name. It doesn't need to be named Atom Shell. And so the first step in Electron was it got its own name. Thank you, Microsoft, for building a text editor. And then that's when I started pushing to build Electron into its own team, moving it out of Atom and really putting a lot more resources into it. And so in May of 2016, this year, we launched the 1.0 of Electron. And so that was awesome, and there's a lot of work in that, and it was really good to get Electron to a stable place. And so Electron is maintained by a small team at GitHub, and by small, which I know is relative places, I mean like 4 people, and then many other contributors, because Electron is a unique project in that it's almost this accidental project that evolved and got really popular, and it's driven more by the community than any other project, really. And so a lot of what's going on in Electron is being influenced by the other companies and the other places that are building on Electron. And so, Slack is contributing a lot of stuff upstream, and it's a really cool project to be involved in for that reason. All right, so that's how Electron came to be, but what Electron is actually made of on the inside can be distilled into these 3 parts. Oh yeah, so even though Electron allows you to write desktop apps with HTML and CSS and JavaScript, Electron itself is mostly C++, and it's combining these 3 things. It's combining Chromium for web pages, Node for file systems and networks, and then it has a set of native APIs for desktop integrations. Chromium is the open source core of Google Chrome, and that's what Electron is using to build upon, but it's not using all of Google Chrome, which is something that is special about Electron. It's just using the part of Chromium that knows how to render web pages, and that makes Electron a little bit smaller, a little bit easier to update, and Electron has this really useful library called BrightRay that lets you build applications with Chrome, because I don't know if anyone here has tried to compile Chrome, but it's not something you want all of your users to have to do, and you don't want people to have to do when they're developing. And so Electron has made that a whole lot easier by not having to have you compile Chrome. And so because Electron is built on top of Chrome, you're getting the latest things that are shipping in Chrome, and Electron updates with stable releases of Chrome. And so when you're designing your Electron apps, you're designing for one browser, and you're using everything that is shipping in the latest Chrome. You can go to can I use.com? And if you can use it in your Electron app, and it'll work across all the platforms. So CSS properties and Shadow DOM and all the things that are coming out, you can use. Of course, you get the DOM that you know and love, and then you also get Devtools. So if you come from a web development background and you're used to debugging and designing your page with Devtools, you can do the same thing when you're building your Electron app with Devtools. And then you get popular Devtools extensions. The word popular there is because not all Devtools extensions are there, but ones for like React and things like that are supported. And so if there is a framework that you like using, it probably has Electron Devtools support. All right, and then Electron has Node. All of Node is built into Electron. Electron's using it as a shared library. And you can use it seamlessly throughout your apps. And having Node means, of course, you get the full Node API. Everything that you can do in Node, you can do in your Electron app. You can use all the code that everyone else has written in the 300,000 plus NPM modules. And if there's something you can't do in JavaScript or you want to do in a low level, you can build or use existing native modules in your Electron app too. And then finally, Electron has a set of native APIs for integrating your app into the desktop, because Electron's it's not a shim around a web view. It's not just showing you a web page. The set of APIs is to really let you build a native app that works and integrates with the operating system like a native app. So doing things like opening windows, changing the style, creating protocols, it's really up to you to integrate as much or as little as you want. Okay, was anybody wondering about V8? Yes, okay. So both Chromium and Node use V8 as their JavaScript engine, and Electron's not using two V8s because in Electron, Chromium and Node are actually sharing one copy of V8. You can set Node to use a different V8 than it normally comes with, and that's what Electron does. And then Electron has Node use the V8 that's shipping with that Chrome. And so a lot of the times that just works. Chrome is moving faster on V8 than Node is, and so it's not always a matchup, and sometimes it means patching Node, but a lot of times not. But this is how in Electron they're just sharing one V8. And so because you're using the latest V8 in all of your Electron apps, you also get things like over 90% of ES6. So if you love fat arrows, go and live your best life and write fat arrows, and you don't need to precompile and do all of that stuff. You can probably just write it as it is. So to recap, you have Chrome for drawing the web pages, Node for file systems, and then they're sharing a single V8, which is Chrome's V8. And then you've got the native APIs. But we can take it further. This is the crazy part where I'm like, this is what I'm going to talk about at this talk. I hope people are excited about that. So I just found this exciting. Chrome and Node both have their own event loops, and there are different projects that have tried to do this in various different ways to make two event loops happen. Sometimes they try to make one use the other one's event loop, like forcing Chromium to use libuv, which is Node's event loop. Sometimes there's a timer that's just constantly checking, is there a new event? Is there a new event? Is there a new event? And that burns up a lot of resources and can make an app really slow. And so this is a challenge, right, for building a framework that's going to combine Node and Chrome. And so what Electron does to figure this out is it creates a new thread, and this new thread lets Chromium's message loop know when there's a new event in libuv, and we're going to walk through it. So when Electron boots up, it's Chromium at the core, and so Chromium is starting with its message loop, and then it's loading up Node as a shared library, and Node is using libuv. But a newish thing in libuv is that there's an exposed file descriptor, and libuv is using this file descriptor to know when there are new events to process. But you can actually listen to that file descriptor yourself, and so Electron has a thread sitting in the middle that is also listening to the file descriptor in the same way that libuv does, And so when there's a new event, Electron's thread knows about it, and then it tells the Chromium message loop to stop, empty out the libuv pool, and then everything starts back from the beginning. And this is how Chrome is able to, Electron is able to make using Node really seamless, make things really fast. You don't have something else weighing down Electron apps. And so Electron, a lot of its speed really just comes down to how fast Chrome is, and luckily Google has a lot of people on that. But the important part of all of this is that you get Node. You get Node totally seamlessly and easily inside of Electron. Okay, so because Electron is built on top of Chromium, and Chromium has a multiprocess architecture, it has a multiprocess architecture so that all your tabs don't crash the other tabs. Electron inherits this multiprocess architecture. And this is the title track. There are two processes in Electron. It has the main process and the renderer process. And the renderer process controls the app's life cycle. It is the place where you start your app, where you quit your app, and it does all of the operating system intensive things like opening dialog windows and things like that. Things that you don't want to happen in another process where people are actually looking at your UI because you don't want to slow it down. And then the main process also creates all of the renderer processes. And then the renderer process is all of your windows in your Electron app. They're the browser windows. It's the part of Chrome that just knows how to draw a web page. And you can have multiple renderer processes. They can be invisible, and I'll talk in a little bit about why you would want an invisible thing. Each of them is a separate process. So just like the Chrome tabs, when one tab crashes, it won't crash the other. You have that kind of functionality in Electron too. In your main process is JavaScript files. It's just like writing Node, and of course you have all of Node. And then you're making use of the Electron APIs that are for the main process, and I will talk about that. And then in the renderer process, just like when you're building websites, your files are HTML files and JS files, well, CSS files too, man. And you've got all of Node, and you've got the DOM APIs, the Devtools, and then you've got all the Electron modules for the renderer process. And you can kind of think of these two processes like Chrome when you think, well, it's like, you can imagine it this way because this is how it actually is. That's why. So if you have Chrome open and you have no tabs open, no windows, but you've still got your menu bar at the top, that's like your main process. It's the place where you are quitting the app, and it's the place where you can click to open a new window. And then each of your new windows is a new renderer process. And then, of course, in Chrome, you can create multiple tabs, and each of those is its own new renderer process, and it's the main process creating these. But of course, you might not be making a browser in Electron. Some people are, but you might have like a menu bar app. And so you can think of the little icon at the top as your main process. That's what's controlling the life cycle of your app. And then the window that people actually see when they click on your menu bar app, that's your renderer process. If you have a more traditional desktop app that has main windows, big windows on the screen, again, your menu bar is like your main process, and then the windows that the users see are each of your renderer processes. So if you are making a mail app, you might have one big window that is for the inbox, but then open new smaller windows for people to compose messages in. And then you can create a hidden renderer process you just create a new browser window and set it to show hidden, and you can actually just farm off JavaScript to this. So places where you might normally use a web worker or something, you can just create a new invisible renderer process so that the JavaScript running in that is not affecting anything loading in the actual visual windows that you have people looking at and interacting with. And finally, you can also have the main process create a renderer process window. And then in that renderer process, you can use a web view, which allows you to have external content embedded in a renderer process that's in its own separate process. Did that make sense? This is what Slack does so that you can't type in crazy code and blow up computers. It is isolated, sandboxed into its own process within a renderer process. So the Electron API and these processes. The Electron API is grouped into modules, and each module is associated with a process. And it makes sense most of the time. So the APIs for creating new windows are called, or that module is called the browser window module. And like we said, the main process is creating new windows, creating those renderer processes. So that's a main process module. But some of them work in both. So for instance, the module for using the system clipboard to copy and paste, you can use that in both of the processes. In the documentation on the API page, there's a list beside each module telling you what process it belongs to. And once you're on the page for that module, you can also see that it's a renderer or a main process module. And so some of these modules are going to be core to like 99% of all Electron apps, right? Most people are going to create some window for users to see, so probably everyone's going to be using browser window. But everyone might not use the system preferences module, which will let you check to see what color theme on Windows people are using, or if on Mac their menu bar is dark or light. It's up to you, and this is, like I said, that you can really kind of go as far to integrating as you want. But another common module will be the IPC and IPC renderer modules, because these are the ways that you communicate between the processes. So we talked about how the main process creates the new renderer processes, but we haven't talked about how you can do anything between them, right? Because if the main process one is the one that can open up new dialogues and people are actually interacting with your window in the renderer process, how does the renderer process tell the main process, I need a dialog window stat? And so that's what IPC modules are for. And so there's an IPC module for the main process and one for the renderer process. And so this is an example of how you would open a dialog window from the renderer process. And so in your script tag, in your HTML, you can use Node. And you would require Electron and the IPC renderer, so the IPC module for the renderer process. And then you would send a message, which you can name anything you want, but you give it a string, a channel name. And then you're listening for that in the main process. So when you make this happen in your renderer process, the main process is listening, and it knows because it's using the dialog module, which it can use because it's the main process. And then it runs the dialog show open error box. And so that's how you would trigger something happening that needed to happen in the main process. There's another module called remote that lets you use the main process from the renderer process. And in my head, get ready, it's like it's a box with rubber gloves, and then you can touch the things that are inside the box, but you're still not in the box. I couldn't think of anything else. And so it lets you have the feeling of being in the main process without actually being in the main process. So here's the same example as before, but using the but using remote. So you can see it's almost the same as we would write if we were in the main process, but instead of requiring Electron .dialog, we do remote.dialog, and that tells Electron that we're using the dialog module remotely from the renderer process. But the thing to know about this, that it's a nice convenience method, but actually under the hood, it's using synchronous IPC calls. So if it's important to you to have things be asynchronous, you should probably just do it the manual way with IPC. And then, of course, if you're doing things with data between the renderer processes, like anything that is in the latest Chrome, all the things that work in HTML5, you can use local storage API, that kind of thing. You can also use IPC to create global variables in the main process. And because you've got Node, you can also just read and write files and save data that way, right? You can create an object, write it to a JSON file, and read it later. This is an app called the Electron Api Demos App And it is an Electron app that demos the Electron APIs. So I've only touched on some of the core modules, but there are a lot of modules. And this one goes into all of the common ones, the ones that you're most likely to use in your app. And it demos them so you can see what they are, and it also gives you sample code. And what's cool about this is because it's an Electron app, the sample code is the real code. We are just FS reading the file and then appending it to the DOM. So it's also cool in terms of maintainability for this app. So once you change the real code, the sample code is automatically updated as well. Yeah, so it's available in the Mac App Store as well. All right, so Electron API and then the different operating systems. So we talked about the Electron API and the different processes, but most of the time, well, all right, back up. So the Electron API has a lot of modules that just work across all of the operating systems. So like the dialog example I was using for like opening up a error message or opening up an open file dialog, you saw that I didn't have to say like, if Mac this, if Windows do this, because all of those common APIs, Electron targets the operating system for you. So you just write dialog, open file dialog, and under the scenes, Electron says, oh, this user is on Windows, so I'm going to use the Windows API. But there are some things that only exist on certain platforms, right? Like I talked about the light and dark menu bar on Mac, right? That only exists on Mac. So of course, the API for that is going to be Mac only. And so there are a few things like this that, well, actually, there's more than a few because there's so many things you can do to integrate your app. There's a lot. But you can check to see what is available and how customized you can get with your app by looking at the documentation, and you can see which APIs work on which platform. But again, the core essential APIs work across all platforms. And so if you're going to use something that only works on one platform, that doesn't mean like now you have to start a new code base. Most of the time you can just handle it with an if statement. So for example, on Mac, you can make your window transparent and you can see the background or whatever is behind it. That's a vibrancy setting, and so you could just set an if process platform is Darwin, set vibrancy. And so that's the extent of what you have to do something custom for your Mac users that wouldn't be something that you could do in another operating system. So it's totally up to you. Like, you can have Electron just open up another website, and that would be the bare minimum thing that you could do. You could start using Node and save things to the file system, but then you could also go down a rabbit hole of totally customizing and really integrating your app with the desktop with all of the APIs that Electron has available. And honestly, there are a lot of things you could do. People were contributing the Sierra APIs long before it came out, and when Electron first came out, or was open source, like I said, like it was built for Atom, so everything that existed in Electron was there because it was something that Atom needed and nothing more. And now that so many other people are building on Electron, you're getting a lot of great other APIs and a lot of ways to integrate your app. All right, and so I'll go briefly into what development is like for the basic Electron setup. And I've tried to, or I guess I kind of try to explain Electron development in these two ways. If you're coming from a web development background, Electron's like building websites, but you get to use Node, and you can get to think of ways to use operating system features that you wouldn't get to do on a website. And you also only have to care about one browser. If you come from a Node background, it's a lot like building a Node app, but you can build a UI for it in HTML and CSS. And you can use your favorite front-end frameworks, or not, or CSS, whichever makes you happy. You can do that. And again, I just want to emphasize that Node is completely seamlessly available in Electron. So in your HTML, in your script tags, you can just start using Node requires if you want. You can do things like checking the platform that the user is on and appending classes. And then, because you could create a whole new Windows theme, right, and a Mac theme and a Linux theme, and you can toggle those in your HTML by just checking the platform in Node, but then appending the class. And then you can read files and write them to the DOM. That's the part that is really fun, I think, and gives you the magical playland feeling with Electron. All right, so because Electron apps are a lot like writing Node apps, you have a package JSON, and in your package JSON, you'll have a field to define where your main process is going to be, because that's the first thing Electron's going to look for is, how do I start up this app? So you point Electron to your main process file, and then in your main process window, you start up your app, and you use browser window to open an HTML file. And so then you have, these are really different colors up there. You have an index.html file, and that's it. These are the 3 components to a basic Electron project, and they represent the processes in Electron. A great way to get started is the Electron Quick Start app, which is this bare bones, a main.js file, an index.html file that you can clone and run. And not only is it a nice way to just kind of see quickly what an Electron app is composed of, but it's also a great way to just start an Electron app, because you get an empty HTML page with the hello world, and you can delete that, and then just start writing your app. And I definitely want to mention that because Electron's also a lot like building websites, you can also make your website, your Electron apps, terribly inaccessible. Please don't. Electron has a Devtools extension called Devtron. Devtron's great in general because Devtron will help you inspect your Electron app, see where you're making synchronous IPC calls and things like that, but it also uses Google's accessibility library to audit your Electron app. And then there are accessibility tools that exist for websites that also pair well. Not all of them do, but the Khan Academy's totally pairs really well with Electron apps, so please use it. And then I have some resources on here, and that's it.